Hello, everyone. My name is Carson Goodrich, and I am in Dr. Torres's spring remote sensing class at Utah State University. And I wanted to share with you what I've learned from my remote sensing tour project. I chose my area of study to be Washington County, Utah, and specifically 3 sites that we'll go over within Washington County, and using the data, the SMAP Hydroblocks data. I'll get in a little bit more as to what that data is later in this presentation. But SMAP Hydroblocks, their spatial and temporal resolution is 30-meter spatial resolution, and they have monthly temporal resolution. So you can get from the year 2015 to 2019 monthly data, and if you recall from class, Dr. Torres shared that the SMAP satellite has 5 centimeters of penetration, so it's able to tell us with some degree of accuracy how much water there is in the first 5 centimeters of topsoil. And SMAP Hydroblocks, they suggested that this could be useful for a variety of applications, including monitoring of drought, crop irrigation, antecedent conditions that trigger wildfires, landslides, and flooding. So I took this data. They provided it to me upon request for free, very, very easy. You just have to convert their netcdf file to TIFF file, and you can work with it in ArcGIS or Google Earth Engine, whatever method you prefer. And I was able to find here on the right, you see a map of St. George is here in red. You see very low soil moisture. This is for, I think it's February of 2019. I know it's 2019, but this map is mean soil moisture for February 2019. And the red indicates low soil moisture. Blue indicates very high soil moisture, or at least relatively in comparison to the other areas. So you'll see like the urban areas, St. George here on the south is very low. And then up in the mountains is blue, like this region right here in the Canara Mountains. If you scroll over, the Canara Mountains is much higher. So I found that to be very interesting. And like I said, we can take this data and look not just for this image, but every month since they started collecting this data. So let's explore 3 sites that I want to dive into a little deeper. Snow Canyon. This is an area of St. George and that I love. It's famous for its ancient lava flows and red Navajo sandstone. I also was interested in looking at an alfalfa field. Despite the rapid development in St. George, there's still many farms and crops that are primarily alfalfa in many regions that are being harvested. So I thought it was really cool to look into this a little bit more. Utah State did some research, and they found that 6.8 million acres of cropland in 11 Western United States have alfalfa. That seems like a lot of alfalfa to me, so that's pretty cool. And then Sunbrook Golf Course. Recently, Dr. Torres showed ET and how they measured the evapotranspiration at a golf course. I think it was in Roy, and he shared how they collected the biomass of different vegetation. And I thought it'd be cool to look at the soil moisture at a golf course. So that's another site that I selected. So how does it compare? How do they compare to each other, those 3 sites? What I found was, I'm going to zoom out just a tiny bit for us. February had the highest soil moisture for the three. And the months of June, July, August, September, October were all very low. And the alfalfa field had the most in February 2019 with 0.2 meters cubed per meters cubed of soil moisture. And Snow Canyon had the lowest at one point with 0.03 meters cubed per meters cubed of soil moisture. So I wanted to take, since I compared 2019, I wanted to take some of the data that I had available for other years and see if 2019 was representative. So I looked and I compared the highest month, which we saw was February, with one of the lowest months, which was August. And I compared 3 other years, 2016, 2017, 2018, 2019. What I found was, yeah, they were pretty comparable in a lot of ways, but 2019 actually had some of the highest soil moisture in February, but compared to other years, but the lowest soil moisture in August when compared to other years. So there was more variability that year. Okay, going into a little bit more of the research and that SMAP Hydroblocks did. I encourage any of you that are interested into looking very far into the methods and understand it fully, with more time that I have in this presentation, to read their paper here, the SMAP Hydroblocks, a 30-meter satellite-based soil moisture data set for the Terminus US. So what they do is they combined a hyper-resolution land surface model, a radiative transfer model, and a Bayesian scheme to merge and downscale coarse resolution remotely sensed hydrological variables to a 30-meter spatial resolution. That, when I read that first, it went over my head. I had to read the paper more fully, but essentially my understanding is similar to how Dr. Torres shared, that they do the sharpening process to take something that's coarse and put some inputs and refine it until you have a 30-meter resolution, because the SMAP satellite is very coarse. I think they use L3, which was like 36 kilometers or something. But I could be remembering wrong, but that's, but yes, but they were able to refine it. And they did pretty well. They compared this data with 4 other watersheds, and it had good correlation with greater than 0.81 correlation to their field measurements, and a good mean KGE score of 0.56. I thought it was important to note that the field observations they compared it to were in watersheds with dense in situ soil moisture networks. So perhaps in this application in St. George, with likely less in situ soil moisture to the watersheds they use to corroborate the data, maybe we won't get as high of correlation as the research presented. Yeah, and I'd encourage you to, like I said, it's free, so you can reach out to SMAP Hydroblocks. Upon request, they'll provide you the 30-meter resolution, or you can just download. They have a site you can download 1 kilometer resolution. And yeah, here are my references for that paper that I just shared with you, and also the USU paper I read about alfalfa. To wrap things up, I just wanted to share my code to show the code I'm going to provide and how you can use it. So I have all of the 2019 images, January through December, and I put them to the same palette and have the same max and min values so we can compare them to each other. And hopefully I didn't zoom out too far. If we compare them, here is December. Oh, yeah, here, let's see. And November, oh, I have to go the other way. February is going to be our highest, if we remember, and then March, April, it's getting drier. May, June, so dry. July, wow, that's so dry. Just so you know, as it's turning from green to orange, that means it's getting has less soil moisture. And then as we get closer to December, more soil moisture pops back up. So yeah, that's what I wanted to share with you guys. You guys can locate this data. I have it publicly available in my GitHub repository. If you go to Carson Goodrich term project, you can put it in your HydroShare Jupyter notebook and see for yourself, explore for yourself. Thank you for your time. Feel free to reach out to me with any questions you may have as you run into me or see me around campus. Thank you.